Hello, today we are going to talk about quadratic functions. Let's consider the quadratic function f of x equals ax squared plus bx plus c. You know that a is the leading coefficient. If a is greater than 0, the parabola opens up and the function has a minimum occurs at x equals negative b over 2a, and the minimum value is f of this x value, that is f of negative b over 2a. And if the leading coefficient, that is a, is less than 0, then the parabola opens down, then f has a maximum occurs at x equals negative b over 2a, and the maximum value is f of minus b over 2a. So you have studied these concepts in quadratic functions in the previous lessons. So today we are going to consider an application problem based on this maximum and minimum values, especially like the maximizing the area functions. Okay, so let's consider an example. A farmer has 2,400 feet of fencing available to enclose a rectangular area bordering a river. If no fencing is required along the river, find the dimensions of the fence that will maximize the area and what is the maximum area. So please read the problem carefully, and we need to find what is given, what we need to find out. And here we have given 2,400 feet of fencing available to enclose a rectangular area bordering a river. So it is given, and we need to find the dimensions that maximize the area. So here the quantity that we need to maximize is the area, right? The quantity that is to be maximized is the area. So first we have to set up a equation for this quantity, that is like the area. So if you consider x is the width and y is the length of a rectangle, we know that the area is length times width, that is x times y. This is the quantity. Area is the quantity to be maximized. So next step is to rewrite this quantity, that is the quantity to be maximized in terms of one variable. You can see that there are two variables in this formula, x and y, right? So to rewrite this area in terms of one variable, we have given another equation here. We have to set up another equation, right? So we have given 24 feet of fencing available to enclose a rectangular area bordering a river. So no fencing is required along the river. So when we consider the perimeter of this, you can see that these two sides, that is the length of these two sides is 2x and this side is y, and there is no fencing required along the river. So the perimeter of this region is like 2x plus y, that is given us 2,400 feet, right? So we got another equation, 2x plus y equals 2,400. So in order to rewrite this area in terms of one variable, first we can solve the second equation for y. So y equals 2,400 minus 2x, or you can rewrite this as y equals minus 2x plus 2,400. Just change the order of the terms. Then substitute this instead of y in the first equation. We can call this equation as like the primary equation. So we can substitute the equivalent expression of y in this equation, that is a equals x times, instead of y, we can substitute minus 2x plus 2,400. Then you can distribute x over these terms. So you will get minus 2x squared plus 2,400x. So we expressed the area in terms of one variable. So we can call it as a function. So we can use the function notation. A of x equals minus 2x squared plus 2400 is a quadratic equation. It's a quadratic function, sorry, of the form f of x equals ax squared plus bx plus c. So this is similar to this quadratic function f of x equals ax squared plus bx plus c with the leading coefficient a equals -2 and b is 2400. That is the coefficient of x, right? So now you can see that the value of a is less than 0, that is -2. Then as per the concepts we have seen in the beginning of this problem, since a is less than 0, the function has a maximum value. So when you consider the graph of this function, it opens down. So the function has a maximum value at the vertex. So we know the coordinates of the vertex are minus b over 2a and f of minus b over 2a. So to find the x coordinate of the vertex of our function a of x equals minus 2x squared plus 2400x, we have to find minus b over 2a to find the x coordinate of the vertex or the x value. So we know that b is 2400 and the a is minus 2. So minus b over 2a is minus 2400 divided by 2 times -2. So that will give you 600. So in the beginning of the problem, we consider x as the width of this rectangular area. So we can say that the width of the fence that will maximize the area is 600 feet. And you notice that since the value of a is less than 0, the function has a maximum value at the vertex. So the width of the fence that will maximize the area is 600 feet. So in the problem, we need to find the dimensions that will maximize the area. So you can see that our question is when the dimensions of the fence that will maximize the area. So we got one of the dimension, that is the width of the fence. To find the length, substitute this x in the equation y equals -2x plus 2400. So we got this equation from the perimeter, right? 2x plus y, so we solve for y. So we can use that equation to find the value of y. So substitute the value of x in this equation. So y equals -2 times 600 plus 2400. That is minus 1200 plus 2400, that is 1200. So the length of the fence, excuse me, that will maximize the area is 1200 feet. So the length of the fence that will maximize the area is 1200 feet. So the final part of the question is, what is the maximum area? So the maximum area is x times y, that is width times length or length times width. So our width is x, that is 600 times length is 1200. So you will get 720,000 square feet. That is the maximum area. Okay. So hope you got this application problem. Okay.